Hi, in this video I'm going to solve another example of linear approximation. In this case my goal is to approximate this sine of pi over 4 plus 0.02. I'm going to let being this f of x equal to sine of x. And here on the left I have this super nice unit circle that we can use as a reference. It's a quite handy reference in most cases. Now let's see, let's start working this through. Our goal, again, we have to use this dy is equal to f prime of x times dx. And well, let's see what we require here. Let's go. So the nearest known value would be in this case, if pi over 4 is equal to 45 degrees, so we have it here on a unit circle. Here are the coordinates that we have. So just remember, the x coordinate will stand for the cosine, the y will stand for the sine. There it is. So, in other words, we could say that f of pi over 4, this is a variable 4, here it is, pi over 4, it's equal, now let's see, sine of pi over 4, that's equal to, as you can see here from the unit circle, it's equal to the square root of 2 over 2. There it is. Now let's get to this is the nearest known value. So let's see, in terms of dy, what we're looking here would be the f prime of pi over 4. This f prime of pi over 4 times the differential of x. I'm going to use green for differential of x. There it is. Now let's look for each part of this dy formula. Let's start with the first one, f prime of pi over 4. So f prime, let's see, if f of x, it's sine of x, well, its derivative, f prime of x will be just cosine of x. So let's see, f prime of pi over 4 will be equal to cosine of, as you can see here from the left, the cosine of pi over 4, it's square root of 2 over 2, just as well as the sine. So I'm going to just write it here, cosine of pi over 4, it's equal to the square root of 2 over 2. Now we are done with this part of the formula. Now let's get to the dx. Well, dx is nearly the simplest in every case. So dx is just the subtraction of the variable, the function, the value we're looking for, which in this case is pi over 4 plus 0.2. Would be pi over 4 plus 0.2 minus the known variable, which is this one, pi over 4. So pi over 4. Now dx would be equal to, as you can see here, well, 0.02. Of course, here I'm using a lot of steps just to be use the ones you require. So well, let's get here the business. F prime of pi over 4, we know it's equal to the square root of 2 over 2. I'm just substituting here in the formula the values we found, times in this case dx, which we know it's 0.02. Now let's work this through. Dy it's equal to the square root of 2 over 2. I'm trying to not using calculator, so this 0.02, it's just the same as saying 2 over 100. It's a very ugly one. 2 over 100, that is. Now we can simplify this out. These two and these two can be simplified. So dy would be equal to the square root of 2 over 100. Now we got dy, but that's not exactly what we're looking for. We're looking for an approximation of sine of pi over 4 plus 0.02. Now, remembering from the previous videos, f of, in this case, would be pi of pi over 4 plus 0.2 will be approximately the same of the value, the known value, which is f of pi over 4 plus the differential we found, differential of y. So in other words, this f of pi over 4 plus 0.02 would be equal to f of pi over 4. We know what's that. That's square root of 2 over 2. Square root of 2 over 2. 2 plus the dy, which we just found, would be the square root of 2 over 100. And well, we could be sure this is actually what we're looking for. This is the approximation we're looking for. And with this, we are done with this example.